Hello and welcome to the channel Let's Learn Electronics. In our previous video, we discussed how P and N regions are formed and how they are combined together to make a diode. That diode is connected to a battery. There are two possible connections, forward biasing and reverse biasing. When we try to forward bias the diode, we connect the anode to the positive terminal and the cathode to the negative terminal. Under such conditions, a significant amount of current is observed. Ideally, the diode is supposed to be a short circuit, but practically some resistance is there, but a significant amount of current is observed. When the connections are interchanged, it is called reverse biasing. The anode is connected to the negative, the cathode is connected to the positive, and under such conditions, ideally the diode is supposed to be an open circuit, but there is some nominal current which is called the reverse saturation current. It is generally represented by Is or I naught, and the main cause of this current is minority charge carriers stuck up in the P and N regions. It's just a quick overview of my previous videos. If you have not viewed them, I would request you to please go back to the channel and watch them first for better understanding. In today's video, we'll concentrate on how the graph, the characteristics curve of a diode is plotted. So let's move ahead. It's a clip from my previous video. I showed you how the battery is connected and how the majority charge carriers, the electrons, start gathering here near the depletion region. They start pushing the junction because they are very excited and they have enough energy to lower the barrier. As the barrier is being lowered, you see this graph, there is some nominal current which is starting to flow, and the moment these electrons start crossing over, you'll see an electron crossing over this junction. The moment they have enough energy to cross the barrier potential, the current starts flowing. There's a rapid rise in this current, exponential rise. And this point where the current starts rising, the current starts to flow, this is called the knee voltage. This is called the cut-in voltage or knee voltage. If the battery voltage exceeds this knee voltage or current voltage, the diode is set to be in a forward bias mode where current is being flown and significant amount of current is observed in the ammeter. Now, on the other hand, if we look at the reverse biasing, the connections are interchanged here. The moment these connections are interchanged, the depletion region starts widening. I have explained this thing in the previous video, how and why it is widened. Now it is broad. It's tough for the electrons to cross over, but still there is some nominal current. Ideally, it's supposed to be an open circuit, but still there is some current. It is measured generally in pico and nanoamperes. These are the reasons of this nominal current marked in red. These are the minority charge carriers stuck up in the P and N regions. They start flowing and we reach to a point when breakdown occurs. I'll explain about that breakdown shortly. But as of now, let's summarize the graph like this. This is the general characteristics curve you'll find in almost every text. I hope you would be able to understand now. Voltage, current, the forward current is generally measured in milliamperes. The reverse current is generally measured in pico or nanoamperes because it's very small. This is the knee voltage. This is the breakdown voltage. I'll mention that, what breakdown is. These are the directions of the flow of current. Now let's see how temperature affects this graph. Temperature makes a significant effect. If the temperature rises, then what happens to the graph in forward region or reverse region? Let's have a look at this video first. If the temperature rises, if it's hot around the device, around the diode, then it quickly starts conducting. It conducts, the knee voltage is shifted to the left. It's shifted to the left. And if it's too cold and winter and chilly, then it takes more time to start conducting. It's shifted to the right. The curve is shifted to the right. And if it is for a change of every 1 degree, 2.5 millivolt change is observed. It either increased or decreased. 2.5 millivolt is increased or decreased on 1 degree C change in the temperature. On the other hand, if the temperature rises, the reverse saturation current doubles after every 10 degrees C. Look, if it was for say for 2 nanoampere here or 2 picoampere here, it becomes 4 nanoampere or after 10 degrees C change. So it's doubling as the temperature increases. So if you would see this kind of graph in the text, you would immediately understand what characteristics curve tries to explain. This graph is for different materials. Like germanium diode has a knee voltage of 0.3 volts. So once the battery voltage exceeds this value, the germanium diode starts conducting, and its breakdown is also comes also very fast. It has a significant amount of reverse saturation current. On the other hand, silicon needs more than zero point 0.7 volt to start the flow of current, and silicon has um, an intermediate level of around 10 picoampere of reverse saturation current, and gallium arsenide needs more voltage to start conducting, but its reverse saturation current is wonderful. It's almost negligible, and it will break down after a long time. Now let me explain you what breakdown is. But before that, let's just have a quick look on the mathematical equation which defines this graph. Every graph must have some maths associated with it. So this is a popular equation which is known as Shockley's equation. It defines the graph. This is the current ID, the forward current, and this is the reverse saturation current IS. This VD is the applied forward bias voltage. N is a constant known as ideality factor. It is either 1 or 2. It is generally mentioned in the text. Vt is the thermal voltage, and you must be knowing the formula how to calculate Vt. If you don't know, it is mentioned here. Boltzmann constant, it's a constant. T is the absolute temperature. You just add 273 to the mentioned temperature in degree C. Q is the magnitude of electronic charge. So you can this graph is based on this equation. So if you if you look at the equation, it is evident that the when the diode is forward biased, this value is into e to the power, this proves that there would be an exponential rise in the plot the moment the diode is forward biased. This value would be more significant, so -1 is it would be negligible, and the graph will rise exponentially. The equation shows it. I just mentioned Shockley's equation in this video. Later on, I'll try to explain it in detail, and also we'll do some numericals. I'll upload the videos for that too. Now let's jump on to the concept of breakdown. What is breakdown? These are the minority charge carriers stuck up in the region. The moment this reverse bias is increased, as this reverse bias is increased, it is energetic enough, its velocity is increased, its kinetic energy is increased, it starts vibrating, and it strikes the adjacent bonds, the covalent bonds, and it breaks them and creates more free electrons. Now more free electrons are ready to strike out another covalent bond, another atom. They are combined together, they start vibrating, they start striking up, and so this procedure keeps on multiplying. They strike more, they break more bonds, more free electrons which are excited, they are generated, and in this way a large number of minority charge carriers are um, generated when the reverse bias is increased to a level which is beyond the breakdown level. There is some limit to there is some limit to the increment of this voltage. Once that limit is breached, once that limit is crossed, breakdown occurs, and this is how breakdown occurs. This kind of breakdown is called avalanche breakdown. In this process, minority charge carriers attain enough kinetic energy, their velocity is so high that they strike out more electrons, and more free electrons are created which are ready to be a catalyst in this process, and more electrons keep on bumping and jumping and striking, and then freshly created electrons multiply this process until an avalanche kind of situation happens. I'll just show you what a real avalanche is. This is a real avalanche, the natural phenomena because of which this process is called avalanche breakdown. Just compare the natural phenomena with the one happening here inside the diode. One electron is vibrating, it's striking up here and there. It is causing more electrons to be generated. Now all of them are excited. Their velocity is increased because reverse biasing is being increased. The voltage in the battery is increasing. Similarly here, more snow is flowing because one ball started to roll down. Look at this scene. A snow avalanche, a natural process. Just like this, a similar situation is happening here. Snowballed. So many electrons because of few minority charge carriers which were so excited that they broke all the adjacent covalent bonds. There is another type of breakdown as well which is called Zener breakdown. Why Zener breakdown takes place? Have a look at this video. This is the junction. The as we keep on increasing the voltage applied here, it's increasing. Electric charge is present here in the barrier potential. This charge becomes strong enough as we keep on increasing the voltage, it's so strong, it's becoming dominating and powerful. And now this strong electric field will break all the covalent bonds. This electric field will be the main cause, the reason which will disrupt the bonding forces, and the when the covalent bonds would be broken, an enormous amount of electrons would be free to flow and the breakdown occurs. This phenomena of Zener breakdown is deliberately employed in a device which is called Zener diode. We will discuss about the Zener diode in the next video, but I hope so far you would be able to understand the characteristics curve of a diode, how the graph is plotted, and how temperature affects that graph, and the concept of breakdown would be clear in your minds. If you have watched this video so far, please click on like, share, and subscribe. And if you need any assistance in academic writing, and if any of my viewers are struggling with dissertation writing and they need some help, then they can connect with us on our email ID, which is let's zero learn zero electronics at gmail.com. It's mentioned on our YouTube channel. Please subscribe the channel and get the updates regularly. Press the bell icon. Thank you for watching.